Welcome to this Open Security Summit session in July 2022, and we have Or doing a follow-up for one of his previous sessions where he's gonna talk about the product permissions, common pitfalls, and definitely a topic that I'm very interested in because in managing permissions and scaling permissions is not a trivial problem. So over to you, Or.
Thank you very much, and it's a pleasure to be here. My name is Weis, as kind of stated before. My background starts in the intelligence corps in the IDF, where I was an officer and developer. I worked in a lot of companies, a lot of startups, a lot of cybersecurity, and then I co-founded a DevTools company called Rookout, in which I ended up rebuilding access control 5 times in a company that wasn't even 3 years old. And that brought me to create the company I'm working on now, Permit.io, which really focuses on permissions. So I'm coming to you today with a full belly on with pain of building access control probably thousands of times throughout my career, and at no point really wanting to do so. So I dove deep into the topic, and built open source and products in the space. So I can come to you today and highlight to you both the pitfalls, but also solutions that you can use to avoid those pitfalls. So you won't have to go through the pain and struggles I went through. So we'll be covering the pitfalls themselves. This is as mentioned before, this is a sequel to another Open Security Summit talk I've given before. So this talk really focuses on the pitfalls, but it also touches on the best practices. If you want to dive deeper into the best practices themselves, I suggest you check out the previous call that, the previous session that is available on Open Security Summit's website. Without any further ado, let's jump in. So first of all, we're talking about permissions, access control, authorization, and probably the first thing we need to address or recognize is that permissions are hard, and they are becoming harder as we're moving more into the cloud, as we're moving more into cloud native ecosystems and into microservices. It becomes harder. So let's spend a few minutes just understanding why it has become hard and what makes it hard. So first of all, it's the infrastructure at scale. If we go back in time to the point where it was just a single monolith that you're building on your own, you'd probably have something to manage the permissions for you. So for example, in Django, you've got, in Python, you have Django with its admin, and with Ruby, you've got Rails, obviously. And with Java, you've got Spring Framework and other solutions that have some basic access control baked into them. But when you're working with distributed microservices and especially if you're a polyglot, you can't use those solutions anymore. So you end up having to sprinkle a bit of access control into every little microservice and component that you're building. In addition, with the scale of modern applications, it's no longer just your services. There are a lot of third-party services that you have to connect to. So think about authentication, which obviously goes hand in hand with authorization. But also think about billing, things like Stripe and ChargeBee and PayPal. And think about databases and analytics and machine learning agents and a bunch of stuff that you combine from external services into what you're building. So the area that we need to cover with access control is actually outside even of our cloud. There are a lot of different data points and spaces that we need to cover. And obviously, if you're doing IoT, if there are physical elements in space that you need to secure access to, that's even wider, larger space. On top of that, the policy itself, the rules and models that we want to enforce permissions for are becoming more complex. So everyone starts with admin and not admin, but you quickly evolve to admin, not admin, and super admin, and then access control lists, and then role-based access control, and then relationship-based access control, and then attribute-based access control, and just keeps on growing. The expectations that we have today from applications and the way we can collaborate in them creates a lot of complex policies. And everything we build ends up evolving, and that obviously adds a lot of that complexity. And that complexity is also dependent a lot of data from those third-party services we just mentioned, but also just basic stuff in our application that we want to enforce access with. So for example, geolocation from your IP address or the time of day. All of these are elements that you now need to combine into your policies, and it's very commonplace and expected. And lastly, security and compliance. If back in the day doing SOC 2 or ISO or meeting GDPR or CCPA were something rare, these are now common standards for basically any B2B app and often also B2C applications. And when you look into those regulations with also HIPAA and PCI, but it's really apparent when you look at SOC 2, a significant amount of the requirements of the compliance is having checks and balances for your access control to the different elements of what you're building. So having good permissions, having good access control really can change the amount of hardship we need to go through to meet the compliance standards that we have to. And obviously applying auditing, being able to have visibility into the access control that you've built and sharing it with your auditors and sharing that with your security and compliance, that's something that, again, is basically expected almost from any solution being built. Maybe not at day one, but probably quickly down the road. And if that's not enough, there's a lot of security friction, actual vulnerabilities that are surfacing up from challenges in building access control. So access control or broken access control is the OWASP top A1 item on the list for things that people recognize as a source for vulnerabilities and friction, with the highest occurrence across all the survey. So this is not only a problem in how we manage and build things, this is also creating security issues in the wild, in our productions, that if we won't address, we'll end up having to face as security incidents. So now that we understand kind of the depth of the problem, let's jump into the main meal here today, which are common pitfalls, common anti-patterns that people often end up implementing into the access control that they're building on their own. And by doing so, failing to meet the challenges that I mentioned before, and often creating those security vulnerabilities that we touched on. So let's dive into those. And let's start with the first one. Mixing up authentication and authorization. This is probably the most common pitfall that people have to face. If I can address the all the people in the chat, if you can refrain from those, that would be great. And from the host managers, if you can close the chat for now, that would be great. So I was at mixing up authentication and authorization. The two are very separate. They both belong to the IAM space. The IAM space is comprised of three parts: identity management, authentication, and lastly, authorization. Identity management are solutions like Okta and Azure Active Directory. They're used on the organization side, where you define the different identities that you have for your organization. Authentication is going into the product side, into the vendor side, and that's where you verify the identities that you have before actually letting them into the product. That's essentially called signing up and logging in. And lastly, we have authorization, where we enforce and check permissions. So based on the identity that was verified in authentication, we'll then do access control or authorization with that identity. The three are obviously related. They trickle down into one another in kind of a waterfall, as described here. But they are drastically different, and we need to recognize that. Some of the confusion is with the concept of roles. You have roles across all of that waterfall. So you have roles in your identity management. For example, you can say a user has a role in the organization. For example, they're the head of marketing, or they're part of the security department. That's a role.
but it's very different from an application level role like an editor or a viewer or an admin. And it's not always clear how you translate the organizational role into the application level role. But it is clear that we have to do that translation. And for each application that we build, we want to put that in, take that into mind and apply that effect and do that translation. So for example, part of our policy can be if someone signs up with for example, the role of head of marketing, we want to give them an editor role for the CMS application. So that's a translation. So the roles are related, but they're not the same. So we shouldn't confuse them. And the other part really touches on how we trickle things down the waterfall. So when we do that translation, the conclusion of the translation, where should it be saved? Should it be saved as part of the JSON web token in the authentication layer, and we can then propagate it through sessions? Or should we save it as part of the authorization layer? The key way to cut things here should be, if it's about identity of the user, it should be in the JSON web token produced by the authentication layer. If it's about policy or making decisions according to the identity, it should be part of the authorization layer. And something that I see very often here talking with customers and talking with fellow engineers is that people have a tendency to kind of overuse the JSON web token. For those who don't know, the JSON web token is a cryptographically signed document that the authentication layer provides and is available for us in the application post-authentication. And some people, for example, would use the JSON web token to even store all the routes that user should access. Now, that's a very bad idea for a couple of reasons. One, it mixes up authentication and authorization, so it just messes up our code to begin with. Secondly, it kind of makes a lot of friction for the authentication layer. So for example, now if we want to change roles, we have to log out and log in the user again, which can also create a bad experience and bad performance for the user using the service. Secondly, the JSON web token is sent for every request with a RESTful API or with GraphQL or basically anything that is HTTP based. So creating a bloated JSON web token would slow down the performance of everything. So that's a really bad idea. And lastly, there's a limit to how much data we can store within the token. So if we end up adding more rules and more rules, we'll end up not having any place to store them if the JSON web token is where we're headed with that. So the best practice to mirror image this is, as I said before, you want the JSON web token to only contain claims and scopes for the identity of the user and their relationship with the organization and the application. You don't want anything about the logic of the application itself or the rules of the application or the policy of the application to be in the JSON web token. So that was our first pitfall, mixing up authentication and authorization. And it's really commonplace and can really be easily avoided just by sticking to that clear line. The second common pitfall is mixing up the app logic and authorization. So we're building an application app, and there's obviously logic for the application itself, what it's supposed to do, and there's logic for the authorization layer. If we combine them into the same code, we end up getting code that is essentially spaghetti. It combines a lot of different elements, a lot of proprietary stuff that if we go up later and we want to either upgrade our authorization layer or upgrade our application, we'll end up to go cherry picking between each element of code and try to figure out, is this authorization or is this the application logic? And the moment you start combining these things, they naturally, organically grow and become more cumbersome. Because an engineer seeing this will say, okay, I'll just shove a bit more of my logic here, which is obviously easy to do and very costly later. Also, you can see here things that are bad for performance. So for example, if for our authorization, we want to check the status of the user, if they're paying. If we do that as part of the application flow every time, that will slow down the application. A better way to do so is to decouple that into the authorization layer and make sure that the authorization layer in the background keeps tabs on who's a paying user or not. So when we come to check that status, it's already available in the authorization layer, and we don't need to fetch it for every part of the authorization queries itself. This is just an example, but you can see a lot of friction points that can arise here. Obviously, the mirror image of this anti-pattern, this pitfall, is to create a separate microservice for authorization. And we'll talk more about that when we circle back to the best practices. Number 3 is mixing up your access control layers. So obviously, we need multiple layers of access control. So we need physical access control, like we need locks on our doors and on our windows. And we need network level access control, firewalls and VPNs and zero trust networks for the devices that connect into the network itself and into our VPC. And we need infrastructure level access control, which service can talk to which service and which services can connect together as the same pod, for example, in Kubernetes, and which services can be deployed, et cetera, et cetera. And lastly, we need application level access control. So we do want, it would be great if we can manage all of the access control that we have in a unified way. If we have a unified interface or back office where we can see all the different layers and all the audit logs and logs for all the different layers, that would be great. And if you can manage all of these as code and do audits on them and do tests for them, and do management for them as part of our source control, that would be great. But we don't want them to be mixed up. There are different demands and requirements that each of the layers have, and different policies and models that each of the layers would have. And here, and maybe to kind of paint the picture, I want to kind of surface the king of the pitfalls that I see here, which is combining your application level access control with the access control built for you by a vendor like AWS for their infrastructure, for the AWS IAM. So initially, that looks like a great idea because they've built a really powerful tool with their IAM. And you can also map a lot of things into objects within AWS. So one of the most common things that I see with customers and engineers is mapping your access control for the application into, for example, S3 buckets in AWS, saying, I'm storing my data in a bucket anyway, so I can use the access control for the bucket for the application itself. So again, it sounds great on the surface, but it's also really easy to see when this starts to break. If you want to move to a different cloud, or even if you want to move to a different storage layer within the same cloud, you don't want to use the buckets anymore. Now you need to use RDS, or you need to use Redshift, or you want to use Snowflake or anything else just because the requirements for your application has changed. Now you also need to completely refactor your access control, which is coupled into the that specific cloud component infrastructure. So that's very clear to see. Another pitfall is within that is kind of relying too much on the way things are built for the specific components. So for example, a lot of people rely on the way you configure the API gateway to do enforcements for your application. And actually there they encourage you to do in kind of a sad manner. AWS kind of encourage you to put routes on the JSON Web Token, like we kind of shared before. They do that there as kind of a hack for kind of a quick sample, and people end up adopting that as something that they can take into production in scale, which is a bad idea. Again, there are different needs for the authorization layer, for the infrastructure, and for the application layer. So we need to take everything with a bit of salt before we take it as is and take it between layers. So to recap here, we do want to have something unified that kind of connects everything for us, but we don't want to rely on it too much. And we don't want to couple it, because when we do want to, because when we come to doing any upgrades or changes, we can suffer from that greatly. Our last and maybe the most deep or most important pitfall is the psychological one. thinking that you can solve it once and for all. I have to admit that I myself fell for that multiple times. Kind of mentioned it earlier. With my previous company, I ended up rebuilding access control 5 times in a very young company. And the thing was that every time I built it, I said, that's it. This is the last time I'll have to face this. I'm building the perfect solution now and I'm done. But every time new requirements came in from customers, from partners, from security and compliance, and I ended up having to throw out what I've built and build it from scratch. The mirror image to this pitfall is to plan for it. Assume that you're going to have to evolve your authorization layer. Assume that you're going to have more policies and more complex roles and rules on top of it. Assume that you're going to move from RBAC to ABAC or something else. Assume you're going to have to build more interfaces on top of this. So you definitely don't have to build everything from day one. That's a horrible idea. Especially if you're doing a startup, if you try to build everything from day one, you'll never finish. But if you plan for things, if you leave room for growth, and if you use the best practices that will allow you to upgrade, you'll have a much better time when these requirements come in. In general, from what I've seen, every company refactors to some degree, sometimes completely, sometimes just adding more capabilities every 3 to 6 months. So that's not very often, but it's definitely more often than most people would want. And most companies go through a classic channel of upgrading their access control policies. And most companies end up realizing that the schemas that they've built for the application, for their data layers, and the schema that they built for their authorization layer are good at the beginning. But then as you move forward, they stop working and you start facing performance issues. So you need to decouple your authorization layer from your application and be ready to upgrade it gradually as more demands come in. So those were our pitfalls. And now let's talk a bit about the best practices themselves that we can use to address those pitfalls. So the first one, which we already kind of touched on, it's decoupling policy and code. So we ideally want to manage our policy as code. And we'll talk about how we can do so with services and open source projects in a minute. But we want to create our policy as code and manage it as a separate microservice. That way we can upgrade it gradually and easily. And here, I think it's really okay to start even with a Lambda function or a simple container microservice that just returns true even, or just runs the existing logic that you currently have in your application. That way, if we separate it out, even if it's almost the same as before, even if it's very simple and primitive, it would be easy to upgrade it in an independent fashion from your evolving application. The second part is, once we have that microservice, is keeping it up to date with the application layer as it's changing. Things like who paid for what, and who's located where, and what's the time, and what's the quotas that we have for our users, and who has a subscription, etc., etc., etc. Those are things that are changing dynamically for every application in real time. Users are swiping their credit card, are changing their settings, and we want the application and the authorization layer to respond to that as quickly as possible. So it will provide good performance and good experiences. The way to do so is by being event-driven. If we can propagate all those events from the distributed data plane into that authorization microservices, our life is going to be much easier. So that's our second best practice. We decouple it, we create a separate microservice, and then we update it in an event-driven fashion, both its policies and its data. The second two best practices are about what we can build on top of that microservice that we described. And here, I mainly want to highlight to you that these are the things that you're going to need. Almost every application you ever used had user management with the ability to assign roles. It has API key management for developers to get API keys with the permissions that they need for their automation. It has audit logs where people can see what they did within the system. It has tenancy management, where each of your customers can be defined as a tenant and add their users to it. Invites, approval flows, the ability to ask permissions from another user, and the list goes on and on. And those interfaces break down into two main silos. One is back office, which means for ourselves as the application developers. So it would be us, the developers, and our DevOps, and our security, our compliance, but also sales and professional services and support and maybe marketing. Access control is a critical experience, and we need everyone to be involved in some degree. So the back office is for us as a vendor, as a developer, to be able to manage this solution for all of our customers. The second part is the customers themselves. They need a modicum of autonomy within the solution we're building. They almost always they'll want it. They'll want to assign some rules on their own. Roles on their own. They'll be able to define some specific rules. They'll be able to invite other users. They'll be able to be on their own to see what they did within the system. So these are interfaces that it's almost guaranteed that we're going to need. That being said, we don't want to build them from day one. At least we don't want to spend too much energy building them from day one. But we want to leave room and capability to bake those on top of the decoupled microservice that we described before. So we just want to keep that option in mind. Lastly, GitOps, and that's maybe not the most important best practice, but my favorite best practice, because it kind of brings everything together here. If we manage our policy as code, we can manage it with all the benefits of code. So we can use our Git repository to do versioning, and we can do tests and benchmarks as part of CI process, and we can do blame and see who changed the policy, and we can do merges between different versions of the policy, and everything that you already know from the world of code. It mainly means that you don't have to reinvent the wheel. The moment you manage your policy as code, you can get all the benefits of modern code flows that you are already familiar with, and you won't have to reinvent them just for your separate policy. And obviously, once we have that code for the microservice and we have the ability to propagate policies in an event-driven fashion, we can propagate the policy from the Git repository as events, which can create that event-driven fashion we described. So those were our best practices. And now let's look at how we can implement them using open source tools. There are a lot of great tools out there. And if you want a slightly deeper review of those open source tools, you can look at my previous talk here at the Open Security Summit. But I want to start with Open Policy Agent. Open Policy Agent is a graduated CNCF project. It's great, it's commonplace, it's battle tested. And in its essence, it's a glorified memcache that runs a logical programming language. So OPA runs with a language called Rego, which is a derivative of Datalog, which in turn is a derivative of Prolog, which means that it's a language that is really meant to write rules with. And you can see an example for a rule here below. And you can load data into it in the form of JSON documents. And then you can query it to get answers to queries for who can do what. So you can quickly see that essentially OPA can become our microservice for authorization. And instead of building it on our own and struggling with performance and struggling with data management and struggling with building a language that would be suitable and ideal to manage permissions and rules, we can use OPA. The challenge with OPA is that it really focuses currently on infrastructure access control. There is no built-in way in OPA to keep it up to date with the distributed changes in the application layer. That's why there's an open source project called OPAL, Open Policy Administration Layer, which, full disclosure, I'm one of the authors of. And OPAL uses a distributed pub sub WebSocket channel
to keep OPA up to date according to topics. So we have this client-server architecture. The server becomes our main management plane. And if, for those of you that are kind of familiar with XACML or XACML terms, the OPAL server is our policy administration point, our PAP, and the OPAL client and OPAL agent are our PDP, policy decision point, together. The OPAL server tracks events from multiple sources, including our policy from a Git repository. And remember GitHub, so OPAL really enables us to implement that best practice. OPA creates the best practice for decoupling policy and code. And OPAL enables us to be event-driven and use GitOps out of the box. So OPAL tracks our Git repository. When we push a new commit with new policy, it will track it and propagate it according to the configuration to the various clients that are listening in for that topic of policy. And then the client would load the policy into the adjacent OPA agent. So when the application comes to query it, it will already be loaded with the right policy. The OPAL client also loads readiness queries and health checks into the OPA agent. So we can use that to also manage it as part of Kubernetes or anything else that has blue-green deployments or gradual deployments, and then gradually scale this out. Both the OPAL server and OPAL client, by the way, are stateless. So they're perfect for any cloud-native deployment. So we talked about propagating policy in real time. Let's talk about data. As we kind of mentioned before, there are distributed multiple services that we need data from. So for example, we'd want our paying users to be taken out of Stripe. OPAL provides a data fetchers mechanism where you can configure or literally write code that would teach OPAL how to fetch data from different sources. So when a webhook, for example, we can sign up for a webhook from Stripe into our OPAL server that will let us know that a new bit of information is available. The OPAL server then would broadcast that to the OPAL clients, and each of them directly would go to Stripe to fetch that data. The OPAL server only sends instructions on where to fetch the data instead of the data itself. That way, the server plane and the PDP plane can be decoupled and don't have to be exposed to the same data. It's basically a per need-to-know basis layout. This also enables us to fetch data that is available within our network, within our VPC, where the OPA agent is deployed. So if it's using a database that is available for the application, for example, it can access it directly because it resides next to it. And again, obviously now when the application would come in to query OPA, it will have the answer for us because the data is already loaded into it by OPAL. So that's OPAL, and it works in tandem with OPA to create that microservice for us, make us event-driven, and allow us to use GitOps out of the box. You can learn more about OPAL here, and mainly in the Git repository. Under docs, you can find examples and samples for how to use this. Another cool thing is that when you use OPAL, it runs OPA for you. So it's kind of already ready to be used. Now that we kind of looked at open source tools that you can use to build on your own, I also want to show you a solution that kind of brings all of this together and uses those same open source tools and all those best practices. So you can use them out of the box and without having to go too much into them if you want. So that's Permit. And again, full disclosure, that's the company that I founded. So let's do a really quick demo. I'll be showing you a simple to-do app where you can define different tasks and assign them to different people. I'll just log in here. And you'll see that I'm using Auth0 for login. Actually, just skip that. But we're using Auth0 here. So the application here is comprised of boards. So we can have multiple boards, which are a list of tasks that we have, and we can switch between them. And we can also, we can also perform different actions on a board, like we can create a new board, we can delete it, etc. Within each board, we have tasks. I need to buy milk. I need to go to the gym, etc. And each of these entries is a task. And tasks, we can perform different actions like creating ones like I did now, deleting them, checking them, etc. Very straightforward. By the way, if some of you, for some reason, want to use this application, it's available at sharedtodos.com. Obviously, there are a lot of shared to-do solutions out there. A lot of task management solutions out there. So we've added access control to this application with permit. So I'll be showing you the policy manager. Here we can define as many roles as we want. So I'll delete a role and create a new one. Let's call it a common security role. Just as an example. And for each role, I can see that we have the resources of the application. So we have a board and a task, just like we saw in the application and stuff. So we described to permit that layout of the application, and we described which actions we can do for each resource. And we can add as many resources as we want. Let's add I don't know, a dog resource. And for a dog, we can pet, we can feed, we can, I don't know, send to vet. And we'll have that immediately added here. We don't actually need that role now, so I'll just remove it. But we have the main elements that are already connected to the application. And now let's say that we want to change permissions. So I already showed you that I can delete tasks, but let's say I don't want to be able to delete tasks anymore. I don't want to enable admins to delete those anymore. So we can just uncheck that checkbox, click save. And when we go back here now, it immediately tells me that I can't do that anymore. And if we check that back and we but remove updates, we'll be able to delete, but we won't be able to update things anymore. And we get an error from that. Obviously, we can also present something more user-friendly, but we can do that as well. And the speed of updates that you can see here, by the way, is a very good demo of OPAL because it shows how things are propagating in real time between the different elements and how they create a good user experience. And by the way, the table that you see here is translated into Rego code that runs on OPA in a container that permit provides. And you can take that Rego code and edit it in your Git repository and add more code to it and change it whichever way you like. But you can get a baseline of policies in Rego without actually having to learn any Rego, which is kind of cool. And the idea here is that you can always dive into the code. You can always use the open source components, but you don't have to. You have a simplified way that you can also enable your other stakeholders to use. But again, you always have the flexibility of diving deeper into stuff. There are also the audit logs, so being able to see who did what in each point in time and filtering it by time and filtering it by different requirements. And managing different projects. You can have different projects with different permissions for different applications and different access keys for them. And a lot of cool stuff that I won't bore you with. But if you are interested in this, you can just go to Permit.io and try it out. It's free. There are for up to 1,000 users. You don't even have to think about paying anything. So yeah, so you can check it out. So that's the that was a quick demo of Permit.io. And again, as I said, it's based on open source. It uses OPA and OPAL, which I described to you. And but it probably support other open source solutions like also and Google Zanzibar down the road. That was the core of the presentation. We covered the pitfalls, we covered the best practices, we covered open source, and we covered an example of a SaaS solution that you can use that will bring this all together for you without you having to put in the effort. But this, I think, would be a good time to pause and hear your questions if you have them.
Hey, sorry, I was just I was just trying to get unmuted. So yeah, so I have quite a number of questions on this, right? And
Sure.
it's really cool the the workflow you described. So one of the things I always think about is like, where is the place that we can start adopting some of these technology and principles? And of course, one of them is the engineering teams, right? And then they have their development, they're doing a bunch of stuff, and there's some interesting projects. I'm actually thinking also on the idea of using this technology actually within security. So what's your understanding and adoption, for example, of security products, right? Because if you look at, let's just say, from my side, right, me almost as a consumer, right, of a lot of technologies, a lot of products, a lot of integrations, a lot of systems that have a lot of privileges, right? Kind of, I want to have this global sense of privilege management, because these days, the security teams sometimes become the single point of failure, right? Like it becomes almost this place where you can be attacked, right? So first of all, what kind of the OPAL and support have you seen in technologies like, for example, Akamai or Splunk or Elastic, or and I think you have Auth there, right? So I would assume anything that does Auth has that. And then first question is, what the adoption have you seen in a lot of security products, and also have you seen security teams using this even just to manage access to the current security tools, ideally even outside of security, like to knock teams or other teams that we want to use the security capabilities?
Terrific questions. So I'll try to cover all of the quickly. So starting with the easy stuff, traction and usage. So OPA is used in companies like Netflix and Pinterest and a lot of others. It's a graduated CNCF project. OPAL is used in amazing companies like Tesla, Zapier, Accenture, Cisco, and many others. You can see a lot of them active in our Slack community, which is mentioned here in this link. Actually, when we created OPAL, we were inspired somewhat by the work that people at Netflix did with OPA. They created a replicator solution, which is essentially what OPAL is, and we kind of derived inspiration out of that. So these are really best practices being used in really top of the line companies. So that's kind of foremost. Going into security and benefits for security and how security can get involved with this. So when I started researching the space, I talked to a lot of CISOs, a lot of them. And one thing that came very obvious early on is that they are really passionate and they really care about authorization and access control, but they are also aware that they are not the ones controlling it. In the end of the day, when requirements come into the product to build these capabilities, they usually end up falling into the R&D and even specific developers building the solution. So I think the main thing security can do is to embrace that and empower the developers to build something that security can work with and bake into good best practices and good patterns that both developers and security won't end up regretting later. And I think GitOps is really a terrific example for it, because the moment you manage things as policy as code, the moment you have a Git repository, you can provide visibility to the security team through that. They can become involved in the auditing phase. They can become part of the code review. They can require tests that will be implemented before the authorization code is changed and sent into production. So I think that's really maybe the most important thing that security can do here. Work with developers and enable them to build things in a way that will be suitable for both sides. Regarding access to the security tools themselves or connecting this to security tools, there are a lot of good integrations in place, both with OPAL and OPA. It's really easy to propagate the logs, both the update logs and the decision logs into your security solutions, into your SIEM SOC, into your logging systems. And that way you can have these things kind of drive one another and enrich one another.
You can use the decision logs from the authorization components to do incident response and do investigations on incidents, and you can also debug issues when they arise. So there's a lot of interoperability here between the security components and the dev components. In terms of enforcing access to the security tools themselves, yeah, sure, why not? In the end of the day, it's just another application. It doesn't matter if it's an AppSec engineer building it or a regular engineer. Regular engineer is probably not the right term. An engineer that doesn't belong to the security department building it. And yeah, so it would work exactly the same, and you'd again enjoy that interoperability that this decoupled layer has. Oh, I hope I covered all the questions and points there. It was there were quite a few.
Yeah, no, I I think really, really good, right? And I think my thinking here is that, of course, that if when you embedded in the pipeline and when you embedded in the development workflow and you actually catch the project at the right time and you do threat models and you, like you said, it's super powerful to be able to get to the point where you're doing compliance and policy as code and that integration and the testing. But sometimes you don't happen to be there, or you come a bit late, or it becomes the project already deployed, or you have all these other things. But also, I sometimes find it's hard to introduce technology, especially on mission critical systems, or basically every project is mission critical for that team, right? So the last thing the team wants is more complexity or more unknowns. I think a good place sometimes to start is actually on the engineering activities done by the security team, right? Because if you think about it, just about every good security team today is an engineering department, right? If they're not, they're just glorified tool fucking users, right? And they're not really scaling, and they're already insane and inefficient. So by design, and a security team will have engineering resources, or will have access to engineering resources, have capabilities. And one of the things that the engineering team, so the security team has access to those. And one of the things that you need to do in security is make sure that your own accesses are secure, right? You make sure that it's very rich to go to a team and saying, hey, you guys should have good DevOps, good workflow, shift left, etc. And then the security team is almost like the worst example of of how to deploy stuff, right? Which I've seen a lot, right?
A cobbler going barefoot, essentially.
Well, exactly, right? I've seen a lot of security teams that when you actually look at their patterns, you're going, hold on, you're holding people accountable, but you're actually not doing the same thing. So I think that there's a lot of good opportunity to try to introduce technology like this, so that in a way, when you go to the developers, when you go to developer teams, you're not saying, hey, let's try this new sort of there's a technology. You're saying, hey, we already use it. We know how to use it. We have experience. We've gone to the pitfalls. It works, and then here is where it can work better. This is where you can work. So I think there's an opportunity to work with security teams that have engineering departments that want to protect their access control themselves, even without forget about the rest of the business, right? Just within the sphere of security, which is actually already quite massive when you really think about it. Like, who needs to have access to what, dashboarding, reporting, like the example of, let's say, the NOC team that should be having access to Darktrace and Zscaler and Akamai and all the other tools that we have, and the SIEMs and all the stuff that we have, right? That and AWS and Azure and etc. Right? So there's already a lot of requirements, and sometimes we go from zero to hero very quickly, right? We go or zero to all of it, and we want to make sure that the right people have access to the right thing at the right time, which is, of course, the point of identity access control, right?
Completely, and I completely agree. I think, first of all, we're all becoming developers, if we like it or not. Security, compliance, sales, marketing. It might be different kinds of developers. Some are local developers, some are security developers, but we're all becoming developers, and writing and managing code is unavoidable. Or at least managing software is unavoidable. It's a part of all of our lives. And the sooner we embrace that, and the sooner we embrace that with good practices, will make our lives easier. And I think your point of driving adoption in the organization is an important one. It's always, when it comes to new technologies, there's always an initial hurdle you need to go through.
Once it becomes commonplace and everyone's doing it, or your organization is already adopted it initially, it's a lot easier. But there's the first step to be taken. And by taking that first step for your organization, you're making sure that it will be easier for the rest of the people to adopt it with the best practices, as opposed to picking something on their own and going into all of the pitfalls without being aware of it. So just by adopting it and making it available in your organization, you're reducing the friction for adopting it and reducing the chances that that other people would make the wrong choices here. So even if you just adopt it for your own use and just put it on the table there, you're doing a lot of helpful stuff. So I completely agree with that. I think that in addition, it's really about building confidence, both for yourself. So even if it's not you using it now, but you getting to familiarize with it when someone else floats this up or someone else starts building something with it, the friction around the discussion would be lowered, and then everything can be streamlined better. And it doesn't have to be, again, it doesn't have to be a specific solution. Like obviously I'd be happy if everyone would go with use permit, but I will also be happy if people use those best practices and open source tools and build things without going into all the pitfalls that I fell into. Because it's just annoying to see people constantly doing the same mistakes.
Yeah.
So just picking something and going with the right motions earlier is really the way to go, I think.
Yeah, by the way, is there a maturity model for this and for tools? And, even from a vendor point of view, it will be very useful to understand how easy it is to integrate, even something as simple as Auth support, right? Because one of the challenges I have now is trying to manage all identities. And then when you look at all the third party and the SaaS providers that we have, some of them still are very primitive in a way, the stuff they support and all the identity access management. So I don't know if there is already a nice maturity model that can be used that is very laser sharp specific for identity access management, that we could also start to hold some of the vendors and the providers into account, even internal things, right? To say, hey, here's the benchmark that we should be doing.
Yeah. So first of all, I think identity access management is definitely a unified space, but I think each of its silos, as I kind of covered in the talk, identity management, authentication, and authorization, each of them are separate and very deep problems. Yeah. Some of them are bigger, some of them are smaller, but they're different problems. And trying to solve all of them in one fell swoop is probably not a good idea. You should probably pick, if you have multiple IAM challenges, you should probably pick one layer, start with it, get to a good baseline, and then touch the other layers. Doing all of them at once will probably create a lot of pain points.
I agree, yeah. But these days, like, for example, authorization, like, it should be done by Auth, right? Like, you should not be getting into the business of that.
So authentication, you mean?
Sorry, authentication, yes. Sorry.
Yeah. So with authentication, there are a lot of vendors and options you can choose from today. So there's Auth0, which I think is what you meant. Yeah. And there's
Auth based.
And there's
Auth based, yeah.
Auth based is and SSO based is the way to go. And you've got vendors that will implement that, and open source projects that will implement that correctly for you. Yeah. In general, things that involve cryptography, I highly encourage people that are not cryptography experts not to do.
Exactly.
So, and that's, by the way, true for across the space for both identity management, authentication, and authorization. So, for example, in authorization, you need to verify JSON Web Tokens, and you need to store the tokens that you create in a secure manner, and you need to generate good API tokens. If you don't do that, at least use an open source project to tackle those pain points. And with authentication, you also have like now there's a new generation. There's the passwordless generation of solutions, like with companies like Stitch and Magic Links and Transmit Security and a really long list of companies. But just pick something, build on top of it, get to a good baseline, and then you can go and looking at connecting all of your identity management needs correctly. Specifically with authorization, what I can recommend is doing a gradual evolution. So start with the best practices, decouple your policy and code, and then if you adopt a new solution and you're migrating from something that you have in place, you can do so gradually. So for example, you can take your existing authorization and you can run it side by side with the new authorization layer. And you can see that they both give you the same results to queries. They give you the same decisions. Then you can gradually fade off the old authorization layer, and then you can propagate the new authorization layer across systems. What's cool is the moment you do that for like one microservice or one application, it will be easier for you to do on other applications. But you don't need to start and do it all at once. Again, with authorization as well. Start with one microservice, one specific application, migrate it, do it gradually, and then you can build confidence both for yourself and for your teammates.
No, I completely agree. All right, man. I think we're on top of the hour. This has been really good, right? I know, like, this is definitely one of the very hot topics, and it's always cool to hear from somebody who's right in the middle of it, right, and try to make it work. And I think it's really cool that you also build an open source space and now putting some stuff on top of it, because I'm also now very sometimes worried when you just see an open source project that is not supported by, some kind of either open source foundation or commercial entity, because it sometimes means that it doesn't have,
Yeah, it might
there's,
die.
there's some gaps, right? Yeah, and there's some of this stuff you do need that level of consistency, right? And also something that is actually funding the active development, right? Which I think is also super critical. So brilliant. Thanks for your time, and I'll see you on the next summit.
Sounds like a plan. Thank you very much.